Then I'm moving into chapter 6 for just a little. Okay, here goes. I'm going to set this up the same way I've set up the others. I'm going to place from the unit circle these numbers to work with. I'm going to go up to 1, in case I need it, down to a -1, as usual. Now, I'm doing the secant. 1 over x. Guys, I'm going to remind you, on the side here, if I can just do it real quickly, on the circle, I know and you know by this point, this is an ordered pair 1, 0. This is 0, 1. Real quickly, -1, 0, 0, -1. This is for 0 radians or degrees, pi over 2 or 90, pi or 180, 270 or 3 pi over 2, radians all the way around. And of course, one complete revolution, we take it right back, and this is going to be 2 pi. That's where those numbers came from. We all know that by now. Now, here goes. I'm looking for 1 over x. Watch carefully. I'm starting at 0. In other words, I'm starting here. If I place 1 over x where the x coordinate is 1, what's my first point to plot? 1. If I move up to pi over 2, which is right here on the unit circle, and I do the same thing, 1 over x, where x is 0. It's undefined. So 1 over 0 does not exist. That means this graph has, as you saw last week, this graph also has an undefined represented by an asymptote. Now that pi, right here, the x coordinate is -1. I'm looking for 1 over that, which will give me a -1, so I'm down here. At 3 pi over 2, right here on the unit circle, I'm looking for 1 over x, where the x is 0. 1 over 0 gives me another undefined, can't deal with it. Gives me another vertical asymptote. And finally at 2 pi, we end it there. At 2 pi, of course, I'm back here. 1 over x, which is 1 over 1, takes me back up to 1. You guys agree? Now you know that's not the graph, but we're going to start. Apply a few points. Ignacio. Yes. That's the way I like to teach this. I know and you know this represents quadrant 1, from 0 to pi over 2. This little interval represents quadrant 2, quadrant 3, quadrant 4. Please tell the class, in quadrant 1, are all the trig functions positive? Yeah. Every one of them, sine, cosine, tangent, all of them. So my secant that I'm doing tonight should be positive. That means in this interval here, which is quadrant 1, my graph, when I finally graph it, should be above the x-axis, positive. And I've got to pick up this 1 point and follow that asymptote. I have no choice. There's one piece so done. It's above the x-axis, representing positive, picks up 0, 1, and follows the asymptote. Next, 90 to 180, right here, pi over 2 to pi, that's quadrant 2. Can you tell me if I'm in quadrant 2, 1 over x should be negative. That means this time it should be below. So in this interval here, quadrant 2 should be below, and I have no choice. If it's below the x-axis, it's got to do something like that. Is that true? Quadrant 3, pi to 3 pi over 2. Guys, I'm going from here to here. That's quadrant 3. 1 over x in quadrant 3 would give me what? A negative again. So it says stay below in quadrant 3. This is quadrant 3 here, guys. So stay below, and we'll try to make this look as reasonable as I can. Yeah, we had this done. We'll come up, and it's going to come back down. Stay below, like that. Quadrant 4, I'm over here. Guys, I'm in here, quadrant 4. I place 1 over x. 1 over x, if I'm in quadrant 4, where x is positive, is that going to be a positive? So this piece should be above the x-axis in this little interval which represents quadrant 4. You guys agree? Some textbooks may let you leave that graph like that. I don't like that. I like to get a full graph. I've got 2 little pieces on the ends. At least I got 1 full piece of a graph down here. Guys, I don't like that. I would like to extend my graph. Now, it's up to you. Would you like to extend it to the left, go over to a negative pi over 2, and continue this little piece here and make a full piece? Or would you like to continue to the right of 2 pi and continue the piece over there? Because I want 2 of these. One will be opening down, the other will be opening up. Now, do I want here, or do I want here? It's up to you.
Left.
Which one you want?
Left.
Oh, you want to go to the left? Let's go to the left. All right, so go to negative pi over 2. And what do you think is happening at negative pi over 2 to begin with? Thank you. Asymptote. Absolutely. And I might suspect, since suggested to go to the left, might the other piece I'm looking for in the blue here, might it over there do this? Yes or no? So now, do I have 2 full branches? We'll call them branches. They should be symmetric. They should look alike. Mine do not quite look alike. They should look alike. But do I have 2 of these? So they want 2 to represent your graph. Now, if I have a student in class who says, Professor, could I have drawn another cycle or finished it up over here? You could have. Add your parent graph to look like that. Have this with this. I would accept that. Since my student told me to go to the left there on this, we'll accept these 2. So I'm going to accept, guys, these 2 as my parent graph. If you don't mind, let me leave it like it is, though. I am going to erase this piece here. We're not going to use it. I'm going to just use these 2. Okay? In fact, let me erase it now. I've got a few questions here. Guys, that's my parent graph for secant. And all I'm going to do right now to close down chapter 5 for tonight is to ask you, with some help, erased. Okay. I need the domain on this secant graph. I need the range on this secant graph. I need amplitude on this secant graph. And I need the period of this secant. Now, someone's going to be clever. My domain, back here, is not negative infinity through positive infinity like it was on the sine and cosine. I see some asymptotes. So you got to write the domain as x cannot be, and you got to pick up all of them. I have negative pi over 2 as one of them. X cannot be that. X cannot be a positive pi over 2. Cannot be that. X cannot be 3 pi over 2. I would assume if I should go on over, the next asymptote may show up at 5 pi over 2. If I went further, maybe 7 pi over 2, 9 pi over 2. So there's a pattern there. You've got to write out a formula to show someone how to pick up all those. X cannot be equal to, Alex, what you got in mind?
N pi over 2.
Hang on. Okay, n pi, I got you, over 2. And Alex, when you say n is supposed to be an element of the integers. -1, -2, -3, and so forth, 0, 1, 2, 3, so forth, no fractions. Alex, I'm gonna check this. Just at random, I'm gonna choose an integer. Let's say 10. If I put a 10, let's put a 9. If I put a 9 in there, that'd be 9 pi over 2. Are you telling the class if I should go down to 9 pi over 2, am I guaranteed there should be an asymptote? Yes. You guys agree? Hang on. Now, I'm trying to use his formula. Let me go back. Now at random, I'm gonna put a 10 in there. 10 pi over 2 would give me what? 5 pi. Are you telling me if I go to 5 pi, which I don't even see where is 5 pi? We stopped at 2 pi. You think at 5 pi on down here, should I have an asymptote? No. So that formula is written up not quite what I want. Does anyone have another way to write it? And I'll show you a shortcut you could do here. Mr. Yes, Han.
2n minus 1.
Whoa. So erase this that Alex gave me and write this as, hang on, 2n minus 1? Like that?
Pi over 2.
Whoa. And still I'm allowed to replace n by any integer, and you're guaranteeing me there's going to be an asymptote there. Okay, suppose I put a 1 in here for n. And with this formula, just replace n by 1, do the arithmetic. I think I end up with what, pi over 2? And was there an asymptote at pi over 2? If I put a 2 in there, 2 times 2 is 4, 4 minus 1 by his formula is 3, I end up with 3 pi over 2. Was there an asymptote at 3 pi over 2? Try one more, let's put a 3 in there. That would be what? 2 times 3, 6 minus 1, 5. I end up with 5 pi over 2. You guys have already told me, Professor, there should be an asymptote at 5 pi over 2. Is that true? He's giving that to me correctly. Now, I don't know Mr. Hahn. Mr. Hahn is an exceptional student. I have many exceptional students in this class. Many. If I were a student seated, and I'd say, oh, how on earth did Hahn get that? Professor, if you asked me to come up with that formula, I may lose it. So I may not know how to find that formula. Maybe my mind's not working as quickly today as it is. I just could not come up with that formula. Here's one way you could do it. You guarantee it's going to work for you. If you don't see that formula directly, like that 2n minus 1 pi over 2, which I love, take a look at one of the asymptotes. I'm going to take a look at the first one. The first one showed up at what? Pi over 2. How much distance is there from it to the next one? How much distance is that to go from this asymptote to 3 pi over 2, that asymptote? Pi. So I could say my x cannot be my initial pi over 2 plus pi n, where pi is the distance between the asymptotes. By the way, guys, did you guys tell me the next asymptote would be at 5 pi over 2? So if you go from 3 out to 5, if I should have done it, is that another 2 pi over 2 or pi distance to go from one to the other? So just put that pi any number of times you wish to, I'm going to start out with the initial, pi over 2. And if you clean this up, Mr. Hahn, I think you and I, this and this, I think are equivalent.
Yes.
You guys think so? With what he gave me so quickly here, do you think this one is equivalent to this? So if you write yours like this, I'm happy. If you cleaned up and write like this, which is equivalent to it, I'm happier. But either way, I'll give you credit. Wow. Now, so we got the domain out of the way. That's the tough part of this. So you guys do it here or here. Range, the up and down, not hard. The range is negative infinity up to what? Negative 1, including negative 1. Union, what is that, bracket? 1 through infinity. That's not too bad for the range. Amplitude, now listen very carefully. You saw what amplitude was on the previous graphs. I described it as the highest point from the axis. Well, my axis is the x-axis. There's no vertical shift going on here. Guys, how would you describe how high is it from that axis? See, it goes forever, doesn't it? It's rising forever. Is there a set number? No, so I can accept it here. Where is amplitude? There is none. We're not going to call it infinity. Infinity's not a number. They're looking for a number. There is none. Period. The ending subtract the beginning of the cycle. My cycle, by the way, guys, includes these two. This is the cycle. I've got to put this and this for one cycle. It ended at 3 pi over 2. Where did we start? I think it's pi over 2, wasn't it, for the one cycle? And that difference is, what was that, 2 pi over 2? 2's canceled. So this secant graph has a period of pi. Do you guys agree? Or are you so tired you'll say, Professor, whatever? I think my students are tired.
Wouldn't it be minus negative pi over 2 because you want us to show both?
What I did this is one side, one piece of the cycle, and this is where it ends with another piece. Is that true, guys? Mm-hmm. So should I pick up both of them? That's what I want before I do this. Shane says, Professor, what you're doing, I understand what you're saying, Professor. You're saying, Professor, this, you got to pick up both pieces. One opens up, one opens down. This started at what, negative pi over 2? Mm-hmm. And where did it finally stop? At 3 pi over 2, did it? She's saying, Professor, 3 pi over 2, subtract, what was that, Shane? Negative pi over 2? Mm-hmm. And I think that's going to give me what, 4 pi over 2, if I do the math correctly here. What was that, 2 pi? Mm-hmm. There's your period for the complete graph. The parent graph. Which will pick up this and this. So you go from here to here. You got to pick up both little, looks like parabolas for the cycle. Guys, we're okay? Now, you know how much time it took before the break for me to do one of those with the, we didn't do it through transformations. Can you imagine doing maybe 5 or 6 transformations on this? Oh my. Am I going to do one tonight? No. Am I going to do one Wednesday? Yes. Maybe not as demanding as that last one you saw before the break, but I am going to do something with a transformation on this secant graph. So guys, please accept this. This is your parent graph for secant. It's going to take this one opening up, this one opening down, takes both. And then your domain, range. Domain is a little strange here, but I wrote mine like this. Mr. Hahn wrote his like this. Domain, range, we got the range out of the way, no amplitude, and then Shane tells me the period is 2 pi. Are we okay with that, guys? Woo! Ignacio, which graph am I down to? I have not graphed tangent, have I? And that's the last one I'm graphing. I'm leaving cotangent up to you guys. I'm supposed to graph tangent. Well, I'm checking my time here. I'm going to save tangent until Wednesday. Why? I'm going to start chapter 6. I'm going to start chapter 6 and save tangent until Wednesday. You'll see why here. Okay, guys, part 2. We're closing out tonight with this. We're going to have fun. The last few minutes of class tonight. You say, wait, Professor, you must be really tired on this Monday. We've already done inverse functions, Professor. You've already quizzed us on it. It was on the exam, right? Now I know the notation. The notation looks like this. Man, I must be tired. Have we not done this before? Now, before I jump into chapter 6, someone remind me some items of interest I should mark here in a discussion of an inverse function. I know the notation. Thank you. It's got to be 1-to-1. Or it has no inverse. It's got to be 1-to-1. Can you remind me of anything else that we know about an inverse right now?
Composite over two.
Thank you. If I do a composite, which I've asked you to do on a quiz or an exam, with respect to x, you had better get x. That's like a check. Something else that someone recalls about inverses?
Now you swap the x and y value and solve.
You're going to interchange the x and the y. Thank you. I'll do that shortly here. We're going to interchange the x and the y. Something else. It's critical. You're leaving out one of the most important parts.
Oh, the domain ring.
Yeah, there you go. The domain of the inverse corresponds with, or is equal to what? The range of the original. The range of the inverse is equivalent to, equal to the domain of the original. Is that true, guys? Now, those are some items of interest that we've already done. You say, Professor, we've already done this. What are you doing here? I'm doing this to close down tonight. I'm going to give you a function and ask you to find its inverse. You say, thank goodness, something I can do. Something I can do. We've already done this in class. Professor just named the function for me. I'll do that interchange and all that business. We've done this. Here's my function. I want to find its inverse. Better expressed like this. I'm going to find sine's inverse. You guys know what an inverse is? Find the inverse of sine. Don't be confused. If I use that -1, it's called a superscript. If this were meant to be an exponent, it would be 1 over sine. No, this is meant to be a superscript to indicate inverse. I'll take someone's suggestion. Who was it? Someone told me. Shane. Shane says, Professor, I remember you interchanged the x and the y. So if you want to find this, please interchange. That's step 1. You say, Professor, put this like this. I think. Go back to the given. Here's my given. If you're trying to find the inverse of that, please interchange the x and the y. Is that true, guys? Now, tell me the most common response when they say, now, step 2, you know what step 2 is? Get the y by itself, solve for y. Tell me the most common response to get the y by itself I've received from East Coast to West Coast, and I've taught on both, and it's wrong. Divide by how much? Sine. Professor, just go ahead and divide by sine. Just divide by sine, and let's take a break, and you got it. Now, hang on. These cancel. Ah, the inverse is x over sine. Sine of what? Just S-I-N? That's sin. Geez, sine, S-I-N. If you put S-I-N, you need what? Sine of something. My something's not there. You can't just divide by initials and have the initials to cancel out. That's all you have, initials, S-I-N. And cancel those out, Professor. I'm done. I'm ready for Stanford. That's the most common response I get from East Coast to West Coast. It's wrong. It's wrong. Bella, tell the class maybe what you might think we may have to do here.
I have no idea.
And you know what? If I was a student, I would say, Professor, I thought maybe you could do what you did there, divide by sine, and well, you're going to be shocked what the textbook does. They're saying have students just go ahead and recognize that it does have an inverse and just leave it like this. Just say that the inverse is written as inverse sine of x. Don't have them to interchange like you did, Ramsey, and lead them into dividing by the initials S-I-N, and those initials canceled out. That's not the way to do it. So they're saying just have them to leave it as inverse sine accepted, as that's the inverse notation. And then we're going to do something with it, though. Now see a hand going up. Yes,
Maybe it will be just a second.
do it again.
Just a second. Because sin inverse is just as SEC of x.
Whoa, 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 hang on. Did you mention E? Did you say E? Oh, I thought you said E. That's one of my final exam questions. Jeez, I thought you had seen my final exam. I have something like this. With a little bit more. That's putting things together by the time we get to the final. If we get there, which we will. No, no, no. So if we accept, the textbook says, please have students just accept that's inverse, is inverse sine x, just use that as your notation, accept that as your inverse. I'm concerned though with this. Ignacio, I just graphed sine, not too long ago. And we accept sine as this. Here it goes. Oh, we got this. This is just the sine graph. We have 0, pi over 2, pi, 3 pi over 2, 2 pi. We got to go up to a 1, down to a -1, and this is sine. And guys, the sine cycle parent graph, we started at 0. I think we went up to 1, did we? Came back down to 0. Here. And back to 0. And we had a graph like that roller coaster shape. And we accepted that as my graph of sine. Is that true? Ignacio. That's what I gave you. I gave you sine. And that's its picture. That's this graph. And I've asked you to find its inverse. And I'll just leave it as, just use the notation, inverse sine x. Can you tell the class something wrong again? In attempting to find the inverse of sine, where you're staring at its graph, and the question is, please find its inverse. What's wrong with it? It's not 1-to-1. It would not pass the horizontal line test. We've got issues, Billy. We've got issues. MIT, Harvard, closed down. We can't do it. It's not 1-to-1. That's where we get to skip chapter 6. And look at chapter 7. Why not? Just skip chapter 6. I'm going to tell everybody, have that inverse. Professor Randy says, just skip chapter 6. Well, here's the story behind this. I'm going to call it the team, the organization, whoever those scientists were back in the day that got together. They made this 1-to-1. So you would have an inverse. They did something to this to create a graph that is 1-to-1. Right now, mine's not 1-to-1. Now, not Ramsey, not SMC, scientists, mathematicians got together and they made this 1-to-1. What did they do on that team? They decided, and it's accepted worldwide. They're saying, let's do this. Let's move to the left on this graph, extend it to a -pi/2. Now, if I should continue my cycle to the left, I think it's down here. If you guys agree. So it goes down like that. Is that true, guys? Still not 1-to-1. So what the team, the scientists decide to do, so all textbooks worldwide will now be able to find an inverse sine, they do this. Hang on just one second, guys. They say, wipe all this off. And look at that little slice. Now, is that little slice 1-to-1?
Yes.
Oh, everybody say it is. Now, was it me who says that? SMC says use that slice, and you go off to Stanford and they use a different slice? No, worldwide we use the same slice. From -pi/2 to a +pi/2, that's 1-to-1, and therefore the domain I'm worried about on this parent graph now on the sine of parent graph. Its domain is what? Negative pi over 2 up to positive pi over 2. Now we'll just do just a little bit more with this before we leave. The range on this little slice, to make it 1 to 1, the up and down is negative 1 to 1, which falls into place with what we were talking about for the original graph. So guys, there's my domain and range. We will accept it. That's the way it looks, that little slice. Now, can someone tell me, I'm not going to graph the inverse tonight. That's just the sine graph. That's not the graph of the inverse. That's just the parent sine graph, sliced off, to make it 1 to 1. So can you at least tell me tonight, before we get close to closing out, can anyone tell me what is the domain on the inverse? We'll write like this. And the range on the inverse, knowing what we know about an inverse. The domain should be equivalent to the range. So easily I can say this. That's right, guys? The range of the inverse should be equivalent to what? The domain, put it down here, of the original, which is chapter 6. Now please don't walk out of here and say, professor says that black graph is the graph of inverse sine. It's not. That's the graph of regular sine, just sliced off. So you don't see up here the graph of inverse sine. You'll see it later on. This is not the graph of inverse sine. But do you guys agree with all this? The domain and the range interchanging? Beautiful. Now to close down, all I want to do tonight with this, because we have done so much tonight, but here goes. I want to try a few things. Yep, here we go. On the side here, find the exact value of these. And then we'll close now. Number 1. We use the inverse notation, inverse sine, 1/2. Hang on. Not going to do any more graphing. Inverse sine 1/2. Inverse sine, we said for the domain, we can use anything caught between -1 and +1. That's my domain. That's true, guys? So I put a 1/2. Am I okay for the domain? Therefore, now I need an answer. Now, can anyone tell me from the unit circle? They gave me 1/2. I'm working with sine. What do you think they're looking for the answer? What do you think the answer is going to be? I heard pi over what, 6?
Yeah.
If I go to the unit circle, is sine of pi over 6 1/2?
Yeah.
Yeah, that's sort of saying it backwards here, the way we have it written up here. Pi over 6. Now, Ignacio, the range we decided must fall between -90 and a +90.
Yes.
One thing about degrees, same thing. Does my answer of 30, which is pi over 6, does it fall between -90 and a +90? It does. So it even satisfies the restriction on the range. You're done. Now though, here's the issue. Can anyone in this brilliant class tell me? I think there's another spot on that unit circle whose sine is 1/2 besides pi over 6. Something else. More obvious. I'm hearing, I think I heard 5 pi over 6. If you check out that unit circle and you go to 5 pi over 6, it also has a 1/2, doesn't it? Sine of 5 pi over 6 in the unit circle, is that 1/2? Now, 1/2 is good because 1/2 from the domain inside there should be by restriction caught between -1 and +1. Well, that's good. Now, on the side there, we think if you thought the answer was 5 pi over 6, because on the unit circle it says it is, sine of 5 pi over 6 is 1/2. What's wrong with this? Is like 150 degrees. Does it fall within this restricted range? This is between -90 and +90. Is 150 caught between? No, even though it works on the unit circle, I cannot accept it because it does not fit this restricted interval. That's why there's only one answer, and there should be only one answer. This is 1-to-1. Next one. We'll practice with this tonight. Number 2, and I brought this in. Inverse sine, -1/2. First, am I allowed to put a -1/2 in there? That's my domain. Well, the domain says you may replace x by anything caught between -1 and +1. That's okay then. So there should be an answer.
11 pi over 12.
Now, I would think, Shane, I'm hearing it, you might try what, 11 pi over
12. Or 6.
6? No, excuse me, 11 pi over 6. Guys, please confirm, at 11 pi over 6 on the unit circle, is the sign, the y coordinate, -1/2? I think it is, isn't it? If you check out 11 pi over 6 on the unit circle, the y coordinate sign is -1/2. 11 pi over 6, Shane, I like that. Now, this is like 330 degrees. Sometimes I think it's easier to think about degrees. That's 330. It works on the unit circle. Now, the range, though, says your answer has to fall between -90 and a +90. Does 330 fall between? No. Even though it works, I cannot accept it.
Negative pi.
Now is, here we go. We're in searching for an answer. If I have the domain in there correctly, and -1/2 is acceptable for the domain, there's got to be an answer. That's not 11 pi over 6. Does anyone have another possibility?
4 pi over
Tell me again.
4 pi.
Oh, no, not 4 pi over 3, that's getting worse.
7 pi over 6.
Oh, 7 pi over 6. Hang on. From the unit circle. Let me convert that real quick. That's 210 degrees. So if you check out 7 pi over 6, 210 degrees. I think that's done in quadrant, what, 3? You would end up with a negative, the unit circle says it is -1/2. So I've satisfied this. Now, 210 degrees. Does that fall between this restricted interval? Darn it. These are working, but I can't accept them. But there has to be an answer.
Negative pi.
Whoa, Ignacio is his professor. Let's be clever. -pi over 6. Hold on. Where on earth, in the first place, is -pi over 6?
Quadrant 4.
It's not in quadrant 4. Shane? -pi over 6 is down here, 30 degrees. I think that's equivalent to what she may have given me earlier as what, 11 pi over 6. Don't they stop the same place? They're coterminal, they use that word coterminal. They share the same terminal side. Is that the same as 330? Is that true, guys? So rather than call it 330, call it what? -pi over 6. Now, does -pi over 6, which works, does that fit within this restricted interval? Is it caught between -90 and +90? Oh, we're going to have fun here. We're going to have fun here. Finding the answer, we found an answer that fits. Next one. Got a few minutes here. Number 3. Inverse sine -1. And I just have one more and then we're going to quit. Inverse sine -1. Where on earth have you seen -1 as the y coordinate on that unit circle? I would think as a student, if I'm correct, is it 3 pi over 2?
Yeah.
I said, well, Professor, this one's easy. At 3 pi over 2, the y coordinate sine is -1. That's 270 degrees. Restricted interval. Does 270 fit between -90 and a +90? Darn it. No. But Maybe I put the wrong domain in there. I put a -1. Is that acceptable for the domain on this? Yeah, I see a bracket there saying, yes, you can use -1. So there's an answer. Negative, I heard it,
Pi over two.
5 or 2. If you go to this position, would you end up at 3, 5, or 2? The other way around. So just rename 3, 5, or 2 as -5 or 2. Now it's gonna fit, and I can accept it. Last one. Inverse sine 3/2. Inverse sine 3/2, and we'll go home. Whoa, tell me again. Oh, he's telling me something about here. He said, Professor, you put 3/2, which what, 1/2? I'm placed inside here. This is my domain inside here. That's the x. Restriction for the x, the domain should be what? Where was it? It's got to be caught between -1 and a +1. This is 1 and 1/2. Quit. There is no answer for sure on this one. I'm outside my domain there. So this has no answer, undefined. And we're finished. Wow. Look at my students. They're so wiped out they can barely get up out of the desk. So guys, I'll see you on Wednesday. There's a short quiz coming up.